Hello and welcome. In this video we are continuing the backtest of the Bollinger Band pullback trading strategy presented by Rayner Teo. We are starting with getting daily stock price data for the last couple of years for all 1000 Russel stocks. Then we are storing those prices in a database. Database knowledge is not required but might be helpful, so I will link some videos in the video description. The database approach is recommended due to the large amount of data we are working with. So first of all, we need some libraries. We need Finance to get stock prices from the internet. This SQL alchemy will establish a connection to SQLite, the database system we are working with, and we need pandas for data handling. So before we are pulling stock prices, we need to know which stocks are actually in Russel 1K index. Therefore, we are just reading out a Wikipedia table containing all Russell stock tickers. Important to note here is that we are taking the index components as of now, resulting in a so-called survivorship bias. We are trying to diminish the bias by taking a shorter time period, so we are not going to backtest over the last 21 but 6 years. Anyhow, we cannot get rid of it by that, and it is still a thing you have to keep in mind. So let's get the current Russell components by reading in a Wikipedia table using pandas read HTML function. So we are assigning symbols, use pandas read HTML function, pass a Wikipedia link to the Russel 1K index, just copy pasting that here. I will just post that in the video description so that you don't have to type that on your own. And we are screening for the third table on this page, ending up with a data frame like this, containing a column ticker, which is containing all Russel stock tickers. So we're using this column and just store that in a list and reassign that to our symbols variable. So we are ending up with a list containing all Russel stock tickers here. And now we are just looping over this list and pull price data for each of those symbols. So we are pulling a huge amount of data now. Right, so let me quickly show you how this loop will work, because within this loop we will store the pull price data into a database. So let's just loop for symbol in symbols, and we're ending the loop after the first element. So we are just getting TXG here, and we will pull price data for TXG by using yf_download, pass the symbol here, start in the beginning of 2015 and end in the end of 2021. And with that, we will pull price data, and as TXG is rather a newer company here, so this is kind of a bad example, but it is how it is. So let's take the second one. Now you see we are pulling price data for 3M here, a known company, right? So as you see, we are getting a data frame like this, starting in the beginning of 2015 and ending at the end of 2021 here. And as you see, we are getting the open, high, low, close data. You know how this data is looking like if you've watched one of my previous videos. And we are just storing this data into a database, and we can easily do that by using pandas to SQL function. Give the table name the name of the symbol, and we have to provide an engine which we have to define. So we are just using engine equals to create engine, and we are creating a SQLite database, and we're just calling that Rayner db.db. And if you're running this loop, you will have to wait, I think it's 10 to 20 minutes. It's a huge amount of data, but once this loop is through, you have it in your local database and can work with this data. So let's start the loop, and I see you in some minutes. Okay, so after some time the loop has finished, as you see here, and we have stored all price data in a local database. So let me quickly show you how you can access this data. So let's just scroll down here. So you're accessing the data using pandas read SQL function, provide a table name. So let's take a popular one, Apple, and provide the engine. And with that, you see that we are getting Apple price data. Works with every data or every stock ticker in the Russel, so Tesla, for instance, also works, and so on. So what you will see in the next step when we are starting with the actual backtest is I'm just looping over the symbols list then and pull price data for all symbols, right? So to just show you in a nutshell, if I'm looping over the first symbols, so that would be GXG, 3M and ABT, I would just pull the data like so, providing the symbol here, and I would get a data frame for each symbol, right? So as you see, first data frame, second data frame, third data frame, and so on. So let's move on to the actual backtest. Let me clean up this notebook a bit for you. Okay, so let's get started with the actual backtest. We need some more libraries here. So basically just the libraries which we have used in part 1 of this video series. So please check that out. Otherwise you won't understand the next steps I'm doing here. So we need NumPy and TA additionally. And here I've created the engine to pull the price data from the just created database. And this is pulling the symbols from the Russel index. An alternative approach would be to just read out all table names from the created database. So I'm just showing you the syntax, how that would look like. Doesn't make a difference. It's just pulling all names from the database where a type is the table. You would end with the exact same list as here. All right. So first of all, we are going to copy paste all functions we have used in part 1 of this video series, right? So first of all, the apply indicator function, which was taking care of calculating the Bollinger Bands and the simple moving averages and the RSI for the exit condition. We also need to copy paste the conditions function, which is just checking if we should buy or sell. I've explained that in part 1 again. And we need the match trade function, which is matching a buying signal with a selling signal here. And that's already it for the functions we need. And now we are just looping over our symbols list, read in price data, and then apply those functions here to each price data frame. So let's create an empty list here. And in this list, we will store all executed trades for all symbols in the Russel 1K. So we are looping for symbol in our symbols list, pull data from the database using pandas read SQL function, provide the symbol, the engine, and we also set the index to the date column. Then we are setting the close price to the adjusted close price. I've explained in part 1 why I'm doing that. And then we are just calling all the above defined function on the pulled price data. So we are starting with apply indicators, then check for the conditions, and then define the trades as match trades function called on the data frame. In the end, we are just appending the match trades, so the actual trades, to the trades list. All right, so let's execute that. And after some seconds, we are getting all executed trades, at least over the last 6 years, on all 1K or even more than 1K Russel stocks. So let's take a look at that. Loop should be through in some seconds. Now it's through. Now you see we are getting a list containing all executed trades. So let's pull that, or let's wrap that list into a data frame using pandas convenient concat function. And we are storing that to the variable trades data frame, ending up with the data frame you're already familiar with if you've watched part 1 here. So we have a matching trade here, buying signal, selling signal here. All right, so this is just the same as in part 1, but for all trades. So we have over 1K rows in this trades data frame. All right, and now the profit calculation for those trades is the exact same logic as in part 1. So I'm creating a profit column here and use the logic we have used in part 1. So I'm shifting the sell price column 1 row back, subtract the buy price and set that into relation to the buy price. And with that, we are getting a profit column here containing the profits. So the real profits in quotation marks are just every second row here, right? Because these values doesn't make any sense. I've explained in part 1 why that is the case. So we only need this, 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 and so on, right? So we can actually create a new data frame just containing only the profits, the buying dates, and the selling dates. So we have way too much information here in this data frame. So what I'm going to do next is create a new data frame, pass the profit values, but only every second profit value as the values. I'm passing the buying dates, so every second value here. And I'm also passing the selling dates, so I'm using every second value starting from the second value in this data frame. So this, and so on. All right, so let's wrap that all in a new data frame. Using pandas data frame function. And then, as I said, first of all, we're gonna add a profit column here. Just use every second row here from this data frame, access the profit column, and use the values. Then we want to have the buy dates. Again, use every second value here. And then just take the index. So the index is the date. And same logic for the selling dates, but we are starting at the second value and just take every second value here. All right. So sell dates. Then this logic starting from the second value here and take the index. So we're ending up with a frame like this, which is really convenient. We have a profit, we have a buying date, and a selling date. All right. And as you see, it's not sorted, right? We have 2021 in the first row, 2016 second row, 2018, and so on, as you see here, right? So we want to sort the data frame, call that sorted data frame, and just sort the data frame by the buy dates. And with that, we are ending up with a sorted data frame, as you see here. Let's actually set the index of this data frame to the buying dates column, just that we have an easier time plotting. So let's say sorted df, set index, buy dates, but we want to keep the column. So drop false. And we're ending up with the sorted data frame just with this index column. Now let's do the profit calculation for this. So we would just accumulate those profits here. I've covered how and why you're doing that in another video, which I will link in the video description. So I'm adding up a 1 to the profits and apply the cumulative product function to that. And with that, we would 47x or 46x our capital, which is, let's say, hard to believe. So if we would plot that, the equity curve would look something like that. But let me explain to you why this is wrong, or this is kind of unrealistic. So let's take a look at the sorted data frame again. As you see here, we are opening a trade 9th of November here, right? And we are closing the trade 12th of November. But we are opening up the next trade on the 11th of November. So we didn't even close the trade before. So we have multiple trades. We have big clusters of trades. And yeah, you see it also, for instance, here. You see it here. And you will see it a lot of times in this data frame. So we have to get rid of this issue and check if the trading strategy is still profitable. So how are we going to do that? We can shift the buy dates column by one row and check if the shifted value of the buying dates is larger than the non-shifted value of the selling dates. So let's take an example. If I would shift the buy dates column by one row, we would have the 11th here, right? And if I'm checking the buying dates being larger than the selling dates now, I would get a false here because this date is before that date, right? So we are shifting and then do the check if this is larger than this, all right? So let's do that. Let's call that array check. So we are taking sorted df buy dates and shift that one row back and check if that is larger than the sell dates. And we're ending up with an array containing Boolean values. Now, as we have shifted one row back here, we have to revert this shift by shifting the array check by one row. Now, if we are doing that, you will see that we are getting an NaN value in the very first row, so we have to fill up that value. And as the very first trade is always a true trade, right? Because there can't be an open trade before that, simply. So I'm just filling up this NaN value with true. And then I'm getting the buying signals, so true if that is a real trade without overlapping positions, and false if I'm already in a trade. I'm getting that in the right order here. So I can simply add a column to my sorted data frame, call that real trade, and assign that here, ending up with the new data frame. There is a kind of hook with this approach, and that is, for instance, if we are taking a look at this trade here. As we are only comparing the prior row here, this trade would have a false value here, even though this trade could have been executed, because we are selling on the 12th and opening on the 13th. But we're getting a false signal as the row before we have the 16th being above the 13th, right? So if you want to get all, so it doesn't make a big difference. It's just like 5 to 10 trades which are missing here. So you can loop over this data frame to get every single trade here, or find a vectorized approach. I wouldn't know how to do that, so if you know, comment below. Anyhow, we have our data frame with our information if that is a real trade or not. So we can screen for only those true values now and assign that to real trades, and just say where real trade is true. And with that, we would have our real trades here. So 100, as I said, some trades may be missing here. All right. Okay, so let's move on analyzing the strategy. But before we are doing that, I want to get rid of this trade yielding 62% loss. I just question the validity of this trade in general, and it's also not in alignment with Rayner's numbers here, right? I'm not trying to make things up here. I just want to be fair to the strategy, and a 62% drawdown would just crush every number here. I don't know what's the background of this trade, but I will show you in some seconds, minutes, depending on how fast we are proceeding, that this trade wouldn't happen as it is shown here at all if we would have followed Rayner's exact exit strategy. So let's get rid of the trade. So this is, by the way, the minimum of all trades. So I can show you that. So if I'm taking real trades, profit min, I'm getting the 62%. So that would be the drawdown. As said, I question that this is the real drawdown of the strategy. So I'm just getting rid of this by assigning real trades without. So this is the tilde doing, do not include that. And I'm just screening for the profit being the minimum profit. All right. So with that, I have my real trades cleaned up for this huge drawdown here. So the new minimum is at, let's take a look at that, 17%, which is in alignment with Rayner's numbers, right? So this is the drawdown of the strategy. The max is 34%, might be questionable as well. I'm going into some details in some seconds why there could be such outliers in this backtest. So let's move on to the winning rate here. So the winning rate is simply, I can do a list comprehension for that. I'm just screening for all positive elements in this profit column here. So I'm just screening I for I in real trades profit where I is larger than 0. So I'm just taking a look at the profitable trades or the positive trades, and I'm taking a look at how many of those trades were for I and real trades were I did too much SQL in the last time, sorry for that. So I have to check if I is larger than 0 here. So I have 65 profitable trades, and I can set that to in relation to the profits in general. So I'm getting a winning rate of 68%, which is perfectly in alignment with Rayner's numbers here, right? Now, let's take a look at the mean profit, real trades, profit, mean. So mean profit of 1.15%, which is roughly in alignment with Rayner's numbers. All right. Now, what else can we check? We could check the equity curve. So just take the profit, add a 1. Take the cumulative product, and as you see, we made 148% win, or we increased our capital by 148%. So this is also slightly in alignment with Rayner's numbers, as I, contrary to Rayner, was starting in 2015. You can take a look at his video, and you can just accumulate the returns on his sheet starting 2015, and you will get slightly the same profit. So this is in alignment, all right? So if you want to plot it, you can also plot the equity curve here. As some of you have requested to include trading fees, I want to briefly cover that in this video. So let's get our real trades frame again, and now you have the profit, and you just subtract a certain fee amount in percentage, right? So you would add a column here, net profit, and just take real trades, access the profit column, and then subtract a certain fee amount. So just be sure that you are taking the fee amount in percentage and take it times 2, because you are buying and selling the asset, right? So let's say we are just taking 0.5%. So we would just subtract it from here. And with that, we would have our net profit, and then we can plot the equity curve again and take net profit instead here. And then you will see the equity curve again. And it has an effect, as you see, right? So people who are commenting that are very, very right with this suggestion. Now, as I said before, there are reasons why I'm excluding the 62% loss, and why I'm also questioning the validity of some trades here. And that is due to the following. So let me show you, let me pull real trades again with all data. So this is the data frame without excluding the trade. And now if I'm taking a look at the time span I'm holding the asset, you will see that this trade is not valid. So I can do that by simply taking the difference between the dates. To be fair, a better way would be to take the business dates here, but you will see that even if we're taking normal days, you will see that these are just too many dates. Right, so this is the trade, 13th, here, this one here, and you see we are holding it for 16 days, right? Even if you take that these are days and not business days, it's just too much, right? Okay, let's summarize. Overall, we are getting comparable results to Rayner. It actually would have been better to include the 10 days exit strategy, as we are getting a handful of trades which are exceeding the 10 days. Additionally, we cannot be sure which of the overlapping trades would have been executed. As an example, I got multiple trades hitting the condition on a certain date. How can I know if I bought the same asset as Rayner without intraday data? Anyhow, I think it would be quite interesting to test this strategy in the actual live market. E.g., the whole Binance universe would be interesting. If you want me to cover that in future videos, please let me know below. Hit the like button if you found this video interesting. I thank you very much for watching, and I'm looking forward to seeing the upcoming videos. Bye bye.